called DGIS, but it's digest. So please call my university name. It's a little tricky, so some stupid government things in that way. But anyway, so I'm from there. So yeah, so last ICRA 2 weeks ago, so I attended there and I saw many learning-related talks, particularly when it comes to butterfly robot. So I feel like classical control framework is going extinct. And here, dynamic working is good. So many people talk about classical control approaches and less learning-related talks. But butterfly robot research is not here. And my talk is classical control of butterfly should go extinct in any way. Okay, so yeah, I have a lot of things to talk about machine learning. So yeah, people think robot dynamics is too complicated, and then they determine to turn to numerical analysis or optimization or big data-based learning. And yeah, they believe enormous data or calculation process will save us. But yeah, machine learns. But what about human? That's my point. We cannot learn anything from machine learning. So I prefer to develop more transparent and tangible control. So it's a code. I will not give a fig for the simplicity this side of complexity, but I will give my life for the simplicity on the other side of complexity. I think that's what all of us are looking for. So I think many people here look for simple, powerful, magical, super dynamic models which can explain and realize natural and fast locomotion. Maybe in dynamic model dynamics or latent space or function, we are looking for some simple one which can explain the repetitive locomotion. One of the most potential dynamic algorithm will be the sleep dynamics, spring-loaded inverted pendulum. But Professor Sehoon, I think some of you know him. He's MPC controller guy of quadruped robot. And when I talk about this thing that he said, have you ever seen any sleep dynamics really applied to a real quadruped robot? And I could not say yes. So he is MPC guy. He learned a lot of optimization using this single body dynamics. But I want to work on that. So how I can achieve this sleep dynamics on quadruped robot? Yeah, many people here we do this kind of hierarchical robot locomotion control. So we have high level, middle level, and low level. But for me, the most important thing is what the signal, or what dimension, or what dynamics, what equation should be shared among these layers. So I think the process between these layers can be called reduction. So we reduce not only the dimension, but something such that upper level control can understand it and design it and optimize it. And yeah, sleep dynamics also can be utilized by or applied by doing a good reduction. So one problem of sleep dynamics is even though you apply force in the vertical way, if you have articulated leg, because of the asymmetry of leg inertia matrix, you cannot get the vertical acceleration. So to deal with this problem, I came up with some idea, the control algorithm, which is based on rotating workspace and biaxial actuator coordinate. And rotating workspace is, instead of utilizing this Cartesian space, we utilize the rotating workspace, which rotate with respect to the point here and the end point. And then we develop all the statics and kinematics and dynamic equation. And then I apply disturbance observer idea. Disturbance observer not only reject the disturbance, but also can modulate some the inertia part. Okay, so yes. And then yeah, I could achieve good dynamic decoupling. And where yes, I could decouple the x directional motion and y directional motion. And my belief is also feedback control can modulate all the inertia or gravity and damping and stiffness all can be modulated by feedback control. So this is the first leg that we developed. So here the jumping is achieved only by its dynamics. So we didn't give any reference there, and we just achieved this bouncing dynamics, and then by applying the external force, we could achieve this kind of jumping. So when it comes to feedback control, there is a difference in the viewpoint between the mechanical engineer and electrical engineer. Mechanical engineer say feedback control, feedback compensation. I'm electrical engineer. For electrical engineer, feedback control design and feedback compensation. So many mechanical engineers, they believe in dynamics. And dynamics is what's given. You cannot change it. But electrical engineer, we think we can change dynamics by using feedback control. So my idea is by changing dynamics as we want, we could achieve if there is a super simple magical dynamic motion. So one of my ideas is just then why not just realize this wheel by utilizing lab. So utilizing disturbance observer and some impedance control, in vertical way or normal way, we could realize this and tangential way, we could just make a velocity control. And then we apply to quadrupedal robot utilizing simplified kinematics, and then design this kind of thing, and you could, work the simulation. And we did not did a lot of things, like no zero moment point of compensation or anything. We just made the tire stiffness and the velocity control on the left, and it could achieve, working like this. And also, videos. Yes, so this is the power of the disturbance observer. If you did not apply disturbance observer when you do this vertical motion, your tangential motion will be deviated by disturbance over the coupling. But if you apply disturbance observer, you can keep the vertical dynamics and or decouple vertical dynamics and tangential dynamics. And also, even while jumping, can keep the vertical direction very steep. Why? No. Vertical direction soft, but tangential direction very steep. So that's what I have done, and also some motion control and even trucking. So take-home message. Yes. This kind of hierarchical motion control is very important, but one thing more, the most important thing is reductionism, what to be shared between these layers. And then feedback reduction by feedback control, I think this is very powerful too. And for feedback control, PID control is not everything. There's other controller. And NDK impedance. So time domain-based impedance design is not everything. You can design impedance in the frequency domain. And the Cartesian coordinate is not also everything you can utilize for taking of states. So I'm not saying feedback control can save the world, but there are many things to be done by still by feedback control. And that's the end of it.
1 minute while Sehoon is preparing. 1 minute for this.
So referring to as slip control been applied to quadrupeds, makes me think of the days of Rex. So that was Kotichek, full homes, and they were very excited about slip. And then they had Rex, which had somewhat compliant legs, and they claimed that that was all slip. So were they, was that true, or was it not slip?
I think it's kind of split, but yes. First, I need to recommend the kind of point to Professor Sehoon Park. He may not know that one. But the other thing is, yes, there may be several types of sleep dynamics realization. But the point of sleep dynamics is, I think, the rotating of space. So describing all the leg motion in terms of rotating of space. And I'm not sure they also apply the kind of idea one. So I will compare this. Yeah, I will change it.
But going back even further, the first Raybert quadruped was making two legs act like one leg.
Yeah, I think that was the
So that
most
was-
powerful feedback reduction.
No, but that was using slip, right, to make a quadruped,
Yes, yes.
very explicitly.
Right, right. Okay, thank you.